In this video, we're going to look at some of the problems that you guys have been working on and work through those. So the first thing you had to do on this page is determine the mass for each object. And to do that, we're going to be using weight is equal to mass times gravity, where g is equal to 10 meter per second squared. This is the rate at which objects accelerate when on Earth. Here they are labeling weight with F grav, so that's the same thing. And here we're wanting to get the mass of each object, so what we could do is take this equation here and rearrange it for mass, and to do that we'll just divide both sides by g. And so that means that the mass of the object is going to be its weight divided by g, which is, again, that's 10. To find the mass for each of these, we are given the force due to gravity, which is weight, and we're just going to divide that number by 10. So in this case, the mass is 60 kilogram. In this case, also 60 kilogram. Basically, you can just move the decimal to the left one time. That's the same as dividing by 10. So here, this would be 800 kilogram. This would also be 800. This would be, so this is 40 newtons, so the mass here is going to be 4 kilogram, and then 20 newtons, that's going to be a 2 kilogram object. Once you have the mass for each object, the next thing to get on this page is the net force. So here, this is, A is an easy one, there's only one force, and so the net force is 600 newtons, and the direction would be down. Okay, this symbol right here just means sum or net. So it's saying add up all of the forces. Here we have two forces. One of them is 400 newtons up, and the other is 600 newtons down. So the net force is going to be 600 minus 400 because they're in opposite directions. And so we're going to get 200 newtons for our net force, and the direction is also going to be down. Okay, and let's look at one more, how to find that net force. So we'll look at this problem here. Here we have two forces that are vertical, up and down, and we have one that is horizontal. The vertical forces will cancel because we have 8,000 going up, 8,000 going down. So those cancel out, and all we're left with is this 4,000 Newton force, and that is going to be to the left. So that's how you find the net force for each one. And let's look at how to find the acceleration now. So to get the acceleration, we can start with Newton's second law, which says F net equals mass times acceleration. And we want the acceleration for each of these. So let's go ahead and solve for acceleration. And to do that, we can just divide both sides by the mass of the object. And so acceleration is going to be the net force over the mass of the object. So for example, for part A, we already found the net force and we found the mass. So we can just plug numbers in here and say acceleration is equal to 600 divided by 60 kilogram. And we're going to end up with 10 meter per second squared will be the acceleration. And the direction for acceleration is always the same as the net force. So the object will accelerate downward. Okay, again, acceleration is the net force over the mass. So here we found a net force of 200 and the mass is 60. And plugging that in, you get 2.3 meter per second squared, also down. And let's look at one more. So here, acceleration is going to be equal to the net force, which we already found is 4,000, divided by the mass, which is 800 kilogram. And we're going to end up with an acceleration of 5 meter per second squared. And again, direction is the same as the net force. So here it's also left. So we also worked through this worksheet here, and let's go ahead and take a look at this one. So let's start with B, And this is a little bit different because for each one of these, they'll give you different information. So it just really depends on what they give you as far as what your path to solving these is going to be. So for example, here they give us the mass and the acceleration of the object. So a quick thing that we could get is the net force here, because force is equal to mass times acceleration. That's Newton's second law. So here we can take the mass of the elephant, multiply it by the acceleration. So that's going to be 10,000 times 8 meter per second squared. And so we're going to get 80,000 newtons. So we know the net force is 80,000. We still need to get these two values here. And we know that the sum of those needs to be 80,000 newtons, and again, same direction as acceleration down, which means that the gravitational force is going to be greater than air resistance. So to get the gravitational force, that's the same as weight. So we can just do weight is mass times gravity. So in this case, that's going to be 10,000 kilogram times g, which is always going to be 10. It's always a constant on Earth, and they tell you that up here. So F grav is going to be 100,000 newtons. Okay, and so to get the air resistance, we know the net force has to be 80,000, and that means that the air resistance must be 20,000. That way, when we do 100,000 minus 20,000, we get a net force of 80,000. Okay, let's look at this one here. We're given mass, acceleration, basically the same things as the previous problem, but this one's going to end up being a little bit different, and you'll see that here in a minute. So net force, again, we'll do F equals ma for that. So we're going to do 800 kilogram times that by 6, so that's going to be 4,800 newtons. Okay, let's get the gravitational force again. That was pretty easy last time, and that's just mass times gravity. So that's going to be 800 times 10, which is going to be 8,000 newtons. And we see that the acceleration is up, which means that the net force must also be up, which means that whatever air resistance is, I'm going to call that x for a minute, that must be greater than gravitational force, 8,000. So here's how we can figure that out. We know that to get the net force, we're going to do whatever the air resistance is, we're calling that x. We're going to subtract the weight or gravity, 8,000, and that needs to equal 4,800. And if we solve for x, then we're going to get 12,800 newtons. 12,800 newtons. So that one was a little bit different than the one we looked at before. Let's take a look at one more here. So we can again start by finding the net force because we have both mass and acceleration. So net force is going to be equal to 4,000 newtons. I'm just taking that 2,000 kilogram, multiplying it by 2 meter per second squared. We can find F grav by doing mass times gravity. So we'll do 2,000 kilogram times 10 to get a gravitational force of 20,000 newtons. We see that the net force and acceleration are to the right, which means that the vertical forces must cancel out. And so that means that the normal force here, that's what F norm stands for, that must be also 20,000 newtons. Okay, so now we just need to figure out what friction is. We can see that the applied force is 14,000 newtons to the right, and we need to subtract a number that will give us the net force, which is 4,000. So that means that friction must be 10,000 newtons. Because we do 14,000 minus 10,000 to get 4,000 newtons to the right.